When you think of what is metabolic dysfunction, just the simplest term, it is an imbalance in the signals that say we're secure in terms of our food and weight versus the signals that say we're insecure and we're in a famine. It's an imbalance in that. So it's either that people have too high of famine signals or they may have too weak of the security signals. So being able to mimic the body's strengthening hormones with pharmacology is fantastic for that situation.
This is Fat Science, a podcast dedicated to the science of why we get fat. No diets, no agendas, just science that makes you feel better. This podcast is for informational purposes only and is not intended to replace professional medical advice.
I'm Dr. Emily Cooper. I've been treating patients with metabolic issues for over 25 years. I'm on a mission to raise awareness about metabolic dysfunction and why diets don't work.
Hi, I'm Andrea Taylor. I've been fat, very fat, chubby, morbidly obese, and done almost every diet ever invented. They all worked until they didn't. I've known Dr. Cooper forever, but when I became her patient and we learned metabolism was the real problem, wow, everything changed, and I've never been healthier.
And I'm Mark Wright. It's time for Fat Science.
Wait, does this podcast make me look fat?
Welcome to Fat Science. It's great to have you here. I'm here with my two friends, Dr. Emily Cooper and Andrea Taylor. Hello,
Hi.
you two.
Hello.
Hi, Mark.
So
Andrea.
this week's episode is going to do a deep dive on what is metabolism. But before we get there, I'd just like a couple of lines from each of you. When people ask you, what's your story as it relates to metabolism, Dr. Cooper, what do you say?
Well, I'm a physician, kind of really oriented towards science, and I love the problem solving involved in the science of metabolism. And so that's kind of my calling.
And you've been treating patients for decades. From Olympic athletes to people who are struggling with fertility because of obesity, and you've treated people with anorexia. You are one of the nation's, I'll say it because you're too humble to say this, you're one of the nation's top experts when it comes to metabolic dysfunction. So we're super grateful that you're here. Andrea Taylor, what's your story?
I am one of Dr. Cooper's patients. I've known her for a very long time, and she was my metabolic detective to figure out what was wrong with me after years and years and years of dieting and not being being successful, but then gaining all the weight back. And she figured out that as I like to say, but she tells me it's wrong to say it. I always say my metabolism was broken. It was broken. And she humbly put it back together, sort of, and with medical intervention. And now at 130 pounds lighter, I am trying to still make it even be lighter. And I'm going through, and it is the most successful I've ever been. And I've learned about metabolism through her. I had no idea that metabolism meant that the brain was involved. Like, I had no clue. I did not do well in science. And she has taught me about science more than I ever sometimes wanted to know, but sometimes, but she's helped me. I've helped her translate.
Mm-hmm.
She's helped me learn. It's been an amazing back and forth. And I'm so happy to be able to share it with other people.
That's amazing. That's awesome. My story is after 35 years in television news, I'm now a podcast host. I got to introduce to Dr. Cooper when we were doing a Get Fit segment on the morning show of a TV station in Seattle. That led to me becoming a patient when she told me that I had metabolic syndrome. And so I was kind of a mess medically back then, 50 pounds heavier. All the numbers were going in the wrong direction. And today, everything's optimal. And I owe that to Dr. Cooper's care. And this has been an amazing journey. And I think, Andrea, you and I have traveled a kind of a similar journey of struggle, frustration, bad health to what today is really a bright picture. And that's what we're trying to offer everybody listening. So, this week's episode, we're going to do a deep dive on what metabolism is, because I think there might be some misunderstanding, I guess is a good way to say it. Because, like Andrea, you said recently, people have been told, well, you have a good metabolism or you have a bad metabolism. And Dr. Cooper, until I was about 28 or 29 years old, I was so skinny. I could eat anything. And then suddenly it changed. And I started gaining weight and started down that path. So let's start from a very basic explanation
Mhm.
of what metabolism is.
When you think about metabolism, it's really all of the chemical processes in our body that generate energy to do things, to think, to do something physical, to digest food, to do everything we do. So I bet you guys, if you named anything that you think the body does, what could you name? It probably has something to do with metabolism, like your hair, growing your hair, your nails, your everything that our body does.
Who knew?
Yes, depends on our metabolism because it takes energy to do it. It's basically work for our body to do every little thing that we do. And where we get the energy to do that is our metabolic system.
So, and it's super complicated,
Yeah.
as I've discovered over the years. When the body takes in food energy, it has to do something with it. Sometimes it stores some of that energy, sometimes it burns some of that energy. But as you said, Dr. Cooper, it really is critical for just
Mhm.
life, everything about our body. How does metabolism become broken, or where does the dysfunction come in?
That's a great question. Most of it really has to do with our genetics, our genes. So it's established when we're born, it's already there, that we inherit a system that's either kind of weight prone, diabetes prone, or what they call weight resistant. Um, and most people are a bit weight prone genetically because there's a lot of things that can actually influence our genes to make us better at conserving energy. So some of it has to do with our original genetic profile and then how things like our environment impact our genes. So, as you know, well, I don't know if you know this, but there are many chemicals in the environment and they're labeled as endocrine disrupting chemicals, and we're exposed to those. So if you start out with a genetic profile that already has you in a weight prone, diabetes prone category, then you're exposed to these endocrine disrupting chemicals in our environment, our everyday environment, that could actually amplify your risk. So I always think of genetics
Talk
as
about
the
what those
most.
could be.
Well, a lot of those are common things that you've probably heard of: BPA, um, phthalates. It starts with a PH, phthalates. But these are found in plastics. And the interesting thing is actually Dow Chemical, way back almost 100 years ago, actually reported that some of the chemicals they were producing alter our hormone profile. So they knew it at the time and they actually, made that public. But we didn't really pay attention to any of it. And so we don't really in our country regulate a lot of the chemicals that we're exposed to that are known to influence our propensity towards diabetes, obesity, heart disease, even cancer risk. But so some people really can handle more of the exposure because they may not have the genetics that already places them at risk. But if you have people who already are at risk genetically and then they are exposed, that will really increase the odds. There's also medications that are used that could trigger metabolic dysfunction, such as steroids. I think, Andrea, you had a story with that.
I had
Hmm.
that.
But steroids, birth control, certain mood medications, certain blood pressure medications, certain cholesterol medications. So there are so many. So it's really good to understand your own genetic risks before you're throwing other things into the mix.
So let's talk about hormones, Dr. Cooper, and the role that hormones play in metabolism. And I didn't know up until recently, like really what insulin was, and that's a hormone,
Yes,
right?
insulin is a really important hormone produced by the pancreas. And what it does, it enables a lot of our cells to actually utilize glucose. And glucose is really our primary fuel that's circulating in our bloodstream. And it is derived from carbohydrates. It comes from carbohydrates in our diet. It can also be generated from proteins in our body. If we're in a shortage situation, we can convert proteins into glucose as well. But insulin is what enables us to actually use that energy, that glucose energy.
So when people have diabetes or prediabetes, what's happening with insulin in those people?
That's a good question. What happens, and we'll try to keep it simple because there's a whole lot of things involved, but we can develop something called insulin resistance, where the muscle cells that are trying to take up the glucose with the aid of insulin, helping to drive it in, the muscle cells can actually say no and put up a wall and become resistant to the impact of insulin. And then when that happens, they can't actually take up the glucose. So the glucose starts to build up in the bloodstream. And then at the same time, the body fat, which also responds to insulin to take up the glucose, the body fat has to accept it because the body fat has no way to resist that effect of insulin. So after a while, your pancreas starts to pump out more and more insulin to try to drive that glucose into your cells, your muscle cells, for energy. And instead, it's actually just driving more of it into your body fat. So, and then after a while,
Wow,
the
that's
pancreas can
fascinating.
actually become exhausted about putting out that much insulin and start to actually develop something called beta cell failure. Beta cells are where the insulin is produced. And so the pancreas can actually fail. And then once it does, the glucose levels just will climb quite high in the bloodstream, and that will flip people into full blown diabetes.
So let's talk about these hormones, and there are a bunch of hormones, and they tell the brain kind of what's going on, right?
Yeah.
I mean, in terms of they give the brain messages, and the brain is receiving these chemical messages, and it thinks it then knows what's happening in the rest of the body, and then kind of directs the body to do this or
You're
that,
such a
right?
good
So
student.
talk about some of
Yes.
the, well, after 10 years, it's starting to sink in.
Yeah.
But talk about some of the other important
Yeah.
hormones when it comes to metabolism and
Yeah,
their role.
that's great. There's a huge conversation going on in the body in the metabolic, what we call the metabolic feedback loop. So there's something called the peripheral loop, which is all of the signals from our body that are collectively sending their messages to the brain. And then it's really up to the brain to decide, well, based on all this information I'm receiving, what does that mean? And what should I tell the body to do about it? And there's this constant feedback loop. But some of the really important hormones can come from our body fat. So our body fat doesn't just sit there, it actually is the largest endocrine tissue mass in our entire body. And when we say
Wow, so it
yes, it
creates
creates
hormones,
hormones.
the
The
fat
body
does.
fat,
Wow.
it creates beneficial hormones. So you get your head.
Who knew fat was
I know,
beneficial?
get your head around that one. But you may have heard,
That's
yeah,
news
you
to
may have
me.
heard of some of these hormones. It's leptin. Leptin is an important hormone that is actually very popular, and it was first discovered in the 1990s. But leptin is a real important hormone that the body fat secretes, and its purpose is really to inform the body and the brain about what the patient these aren't patients, what the person's body weight is. So it's really informing on the body weight, and so it's considered a security signal if it's saying, "Hey, we weigh enough." One of the problems,
Wow. So if that's
yes,
out of whack, you could be 300 pounds or 400 pounds, and the brain is getting a false signal,
exactly,
right? From
because
the leptin.
it can things like diets, going on a diet,
Mhm.
Right.
fasting, not getting enough carbohydrates, eventually puts your body fat in a state where it's trying to hide. It's basically
Hmm.
not emitting that leptin. And so there's a false belief that you've lost a tremendous amount of weight, much more than you really have.
And it could give
Misinformation
misinformation.
could be saying that you're dramatically underweight when you're actually quite overweight.
Wow. So the result of that is you store too many calories, right?
Exactly.
Hmm.
Your brain directs the body to just store more body fat, because it's alarmed and perceives that you're actually in a famine type situation.
We've heard also about ghrelin. That's another
Yeah,
hormone, right?
that's another one. Yeah. And ghrelin is almost kind of an opposite type of hormone. Ghrelin is really the only major hormone in our body, the peripheral pathway, that sends a signal to the brain that says we're starving. All the other signals coming from the body can be beneficial. It's just a matter of whether their levels are strong enough or if they've been suppressed for some reason. But when it comes to ghrelin, ghrelin's produced in the stomach, mostly the lower part of the stomach. And that's where about 85% of it is produced. And ghrelin is nicknamed the hunger hormone, but it doesn't necessarily make you feel hungry, though it could. But it tells the brain that the body is too hungry. So then the brain responds by saying, we're in a famine, conserve energy, store more fat. When you eat, let's try to prevent you from feeling satisfied so that you could just keep eating more. And the hard thing about ghrelin is certain funny things stimulate it too, like stress, pain, if you're in pain, chronic pain, and even just being annoyed can increase our ghrelin levels. So, but lack of sleep affects both ghrelin and leptin. Sleep apnea affects both of them as well. So there's so many things that can go wrong, and those are just two of the hormones in the pathway.
Wow. Andrea, what's the biggest thing that you've learned about your metabolism since you became a patient of Dr. Cooper's?
I had no idea that sleep and annoyance and any of that stuff, like the brain, any of those things would affect how your body reacted to something. And when I went through a bunch of testing, I found out that my body thought that I weighed about 85 pounds. And that was, I think I weighed at that point maybe like, I don't know, like maybe 280 or something. And I was like, well, I think that my body is really stupid because like it's not really calculating
Well,
very
and
well.
Andrea, that was that
But
leptin that we're talking about, the leptin. And
yeah,
why do you think that was so low? Do you have an idea why?
right. I forget
Well,
what
think
was
about
that. I don't know.
all your diets,
There
30,
was
36
oh all the diet.
diets.
Oh right, it was all the dieting because it was like I messed it all up by like jamming the
Yeah, that was
signals.
the diet
It was
damage.
basically I damaged every signal that could be by doing all of that and telling my body that, oh, you're okay, you're okay. But it was not okay. Everything was wrong. And I mean, honestly, it's still wrong. So it's never going to totally
Yeah, you never
fix,
know.
but
Have
it will
hope.
be maybe. We have hope. We have hope. I
It's a
mean,
journey, it's a long
but
process.
it's a long process, but it's crazy. Like, who knew? I had no idea. No one had ever
Yeah.
figured that out.
Dr. Cooper, tell us what, when we sleep, and I remember when I was anchoring the news in the mornings and had to get up at 2:30 in the morning every day. I remember that you were always asking, "Are you getting enough sleep?" And I would say, "No, I'm always tired." Explain why sleep is so important to the creation of certain hormones that regulate metabolism.
Well, many really important hormones are secreted while we are asleep. And so, what's interesting is the timing matters also. So, between about midnight and 2 a.m., our ghrelin kind of reaches its peak for the past 24 hours. And between 2 a.m. and 4 a.m., our leptin reaches its peak for the 24 hours. And as you know, those two hormones are opposite. So if you stay up really late, your ghrelin actually reaches a higher and higher peak the later you're staying up. It doesn't have time to settle down, it just keeps increasing. And if you wake up early and disrupt that 2 to 4 a.m. period, your leptin doesn't fully come up. So the end result is if you wake up in the morning and you've had either not enough sleep, usually they show like less than 7.5 hours can alter your hormones, or if you've had interruption in your sleep because of staying up too late, waking up too early, then your metabolism the next day is affected by that. You'll have higher ghrelin, lower leptin, so lower satiety signals, lower metabolic rate for that next 24-hour period.
Wow.
So what's the ideal? We go to bed earlier and get up later?
Well, go to bed earlier so that you're well asleep between that 12 to 2 a.m. And that's really hard with like college students. I find it's the hardest.
Hmm.
But then poor Mark, when you were on your shift, you had to wake up between that 2 to 4 a.m. every day of work because you were doing a morning show. So
Yeah.
that was something almost like an occupational condition that
Right.
you really had.
And
Because there was not much you
it
could
caused
do.
my body to store a lot of
It
calories
it
as
did.
fat. So I just
Yes.
couldn't get rid of that belly fat
Right.
during
That's
that
the end
time. I
result.
have to
Mhm.
say though that I just and we should explain, I guess, to our listeners, the way that you measure all of this in your patients is that about every 4 months, we have extensive blood labs where we come in. Your technicians draw blood, we eat, and then they take blood 30, 60, 90 minutes after. So you can see hormonally what's going on with our bodies in terms of how we handle the food. But I
Mhm.
should say that this last lab that I had, you looked at my stress hormone, and I think you said, "Wow, I don't think it's ever been this low," or "It's been
It's true.
years
Yeah.
since." And so, and I think about, well, what's the biggest thing that's changed? And I started this job at the first of the year, and it's a 4-day work week, and it's the most ideal job I've ever had in my life. And there's absolutely that connection, and we can measure
Yes.
chemically
You
how much
can.
healthier I am.
That's
Yeah,
so
isn't that wild?
crazy.
Well, also, ghrelin increases cortisol. So if your ghrelin is high, your cortisol levels do go up, and that's a stress hormone.
Hmm.
So yeah, there was a big difference.
Yeah, yeah, huge
Our
difference.
lifestyle matters. Our body can only handle those kinds of schedules for so long, and before it starts to really suffer.
Is there a fix that you can do to somebody's metabolism? Is a broken metabolism always broken?
Well, there's a lot of reasons. So there could be people who have like really strong genetic dysfunction where something really will not work on its own ever, you know. But fortunately, we can actually use pharmacology to help even with people like that. But they may require this, forever, that type of pharmacology. But it depends on how long you've lived with these metabolic disturbances and what you've tried to do to cope with them. So, for example, in your case, Andrea, you have had this lifetime of diets that caused this superimposed layer of dysfunction on top of whatever the original problem was. So, that takes just as long to reverse that diet damage as it does to actually get to the root of the original problem. So,
Right. And I think that, like, between
yeah,
us and
yeah.
whatever, I think I'm willing to live with my pharmacology for the rest of my life. I'm
Right.
not, the magic of medicine and
Uh-huh.
whatever is fine with me because I'm like, you know what? If this is going to help me and it's going to work,
Mhm.
okay, I'm fine with that.
Right.
And I think you have to, in your head, once you start with something like that, you have to make that agreement with yourself to say, this is what's going to work. And you have to work with it as opposed to against it. And if I can be on less medicine as we go forward, great, which
It
has
has happened.
happened. And we've changed it around. I look at it as my medical
Hmm.
cocktail that changes every few months or whatever.
Yeah,
Mhm.
But it's something that has to happen. It's not something that just can happen with
yeah,
nature,
yeah.
and it can happen with it's not going to happen with a diet, and you have to like switch your head to think it's not going to happen if I only
Yeah.
eat grapes or if I only eat cabbage rolls. That's not how it is anymore. That's not the world.
So let's talk about some of that pharmacology, Dr. Cooper. And I think what's interesting, I think there's a lot of judgment when it comes to this. I applied for some life insurance recently, and I was rejected. The sad thing is that all of my numbers, cholesterol, blood sugar, blood pressure, everything was absolutely optimal. But they said you're on too many medications, and I was like, so I'm super healthy, but I'm taking some medications
Um,
to make sure that I'm super healthy, and we get penalized for that. That's probably, I'm going off on a rant,
no,
so
but
I don't want to.
but that's comparing yourself to someone else who isn't on maybe pharmacology, but also has never been diagnosed with what they actually have going on.
Yeah.
So,
Yeah.
undiagnosed person who's at more risk.
So, what are some of the medications that you put people on to help regulate the metabolism?
Well, sometimes it's something very simple. It could be something really simple that's just correcting an imbalance that, if it persists, it keeps disturbing the brain and making the brain kind of perceive this famine. And then other times it's more complex. And the really great thing about living in today's environment is we're kind of on the cusp of a lot of discoveries in terms of the pharmacology for what we call diabesity, either type 2 diabetes or obesity or related conditions, metabolic syndrome. And some of these discoveries have been over 100 years in the making, but they're finally getting medications into the hands of people today that really need them. But most of the real sophisticated pharmacology today and what we'll see in the future is really just trying to mimic the body's favorable signals. So it's taking our hormones that our body is producing that we discussed, coming from our body fat, comes from our GI tract, different places that our body's sending signals to the brain about whether we're nourished or we're in a famine. And the pharmaceutical industry is mimicking those actual biologic agents now and creating their own cocktails where they can piece together two or three of those in levels that would be considered healthy, beneficial levels for someone's metabolism. And that person that is having this problem could take that medication and it would actually put them into a more normal metabolic profile. And we look at people with low thyroid and we say, oh, you need to take a thyroid supplement. But when it comes to metabolism, that's kind of what we're talking about. People with metabolic dysfunction that have hormones that aren't really operating according to normal levels or normal function can take a replacement today and in the future. And the future is going to look very bright because they really are looking at many of these bioactive substances our body produces and mimicking them. And they're all in the pipeline now, everything that they could
Right.
think of. And it's a really good direction.
And I think that when we stop referring to them as weight loss drugs, I think the world will be a better
Right.
place. Um, I think that that is part of the thing that makes them sort of feel like the person is being weak. I think it plays into the whole
Stigma.
like, oh, fat people are weak. They're taking drugs to lose weight, and all they do is take a shot and then they lose weight because that is not how it works. Um, you don't take a shot and then, oh, next week you're down 20 pounds. That's not how it
No.
works. But, and I think that they should not be referred to as, that's sort of a PR negative connotation with them. But I like that you were calling them hormone replacement drugs
Yes.
because I think when you refer to hormone replacement, that is really what they're
Hmm.
doing. They are boosting what we have that's
Yes,
broken.
they are. They're repairing that and they're
Yeah.
changing that pattern. When you think of what is metabolic dysfunction, just the simplest term, it is an imbalance in the signals that say we're secure in terms of our food and weight versus the signals that say we're insecure and we're in a famine. It's an imbalance in that. So it's either that people have too high of famine signals or they may have too weak of the security signals. So being able to mimic the body's strengthening hormones with pharmacology is fantastic for that situation.
But I would love to call them like another kind of hormone
Yeah,
replacement. I think that
metabolic
that would be
hormone
so,
replacement. Hmm.
yeah, I think that would be like
Metabolic medications.
a really
Yeah. Mm.
positive way to talk about these
Hmm.
drugs, much more than the way they're being
I've
talked
tried to
about
talk
now.
to the drug companies about their language.
I know it would really, but I think it probably is not as instant moneymaker as a weight loss drug. Like
Well,
people are like chomping on
unfortunately, I
that.
kind of see that the diet industry is so successful, financially. And
Oh,
so I think
yeah,
the pharmaceutical industry and the medical industry are sort of playing and trying to ride that as well, that
yeah,
same kind of framework.
Hmm.
yeah.
Is there a way for people, Dr. Cooper, to know that they have metabolic dysfunction or metabolic syndrome? Like what would be some of the things that we could know ourselves? I know that, blood work can
Yeah.
prove it. But is there a way to know?
Sure, because metabolic dysfunction is like a big overarching term for the general disturbance in your metabolism that causes abnormal weight gain, abnormal appetite, abnormal blood sugar levels. So if someone feels like they're in that mode, they have metabolic dysfunction, even without any lab tests. It's like, okay, you have metabolic dysfunction because you're not sensing when you're eating potentially, or you are, but then you're doing X, Y, and Z for your nutrition and your exercise, and your body weight is very resistant and keeps going up. It doesn't add up. I mean, you have metabolic dysfunction. Now the question is, where is that coming from? What type? What can we find out about that dysfunction? That requires a deeper look with labs. Metabolic syndrome is a type of metabolic dysfunction that's high risk because it can lead to heart attack, strokes, and diabetes. So that is easy to determine through blood tests with your doctor. If you happen to have high blood pressure, that's one of the features potentially. It doesn't mean everyone with high blood pressure has metabolic syndrome. But if you have high blood pressure, you have to think, do I have any of the other features of metabolic syndrome? And I think we'll do a segment on that, a session on that. But in general, if you have high cholesterol and you've got maybe prediabetes or high body weight and you have hypertension or high triglycerides, it's like, oh, you probably have metabolic syndrome then. So that can be determined easily from simple labs, metabolic syndrome. And the problem then is piecing it together and not thinking of it as separate things, thinking of that these things have a common underlying physiology that we need to target, not just put you on a blood pressure medicine and a cholesterol medicine. We've got to find out.
Right. Looking at it as a whole as opposed to individual things. And I think as you get older, because of all those things having a confluence happening all together, it kind of is more common.
Yeah, very common. Very common. Yep. And it is so common that, as Mark was saying before, it's kind of dangerous because now we are seeing more heart attacks, we're seeing more diabetes, and those are linked into that metabolic syndrome risk. And again, preventable if you identify the risks early and you try to target that underlying metabolic dysfunction that's causing it.
Well, this has been a super interesting conversation about what is metabolism. And for those of you listening, you probably can tell there are so many sort of subjects to metabolism and metabolic dysfunction. And we are going to go down each of those rabbit holes in the weeks ahead. Like, what are carbs? Are carbs bad for you? And just all that other stuff. And medications, we're going to have a separate episode on medications as well. So this is just the beginning. Andrea Taylor, Dr. Emily Cooper, this has been fun. Thanks.
It's been great being here.
Fat Science. No diets, no agendas, just science that makes you feel better.
I'm Mark Wright. Thanks for listening to Fat Science with Dr. Emily Cooper, a Work P2P production. New episodes drop every Monday. If you've enjoyed the conversation, subscribe, rate, and review this podcast. This production is for informational purposes only and is not intended to replace professional medical advice. Join us next week for another episode dedicated to the science of why we get fat. No diets, no agendas, just science that makes you feel better.